In this video, I'll teach you about random variables, how to compute the mean, and how to compute the standard deviation. So we'll start with an example. If you buy a $5 lottery ticket, you might win the $1 million jackpot with a 0.00001 probability. If you don't win, you're out your $5. So what we have here is sort of a classic example of a discrete distribution, and it's a random variable. It's random because we don't know what the actual outcome is going to be. We can tell with a certain probability what outcome it could be, but we can't predict the future and say what the outcome is going to be. That's what makes this random. So with our variable, we're going to use the letter x. You can actually use any variable you like, but x tends to be pretty common. You could also use w. W could stand for winnings, or any other letter of the alphabet. We tend to stay away from ambiguous letters like O's because they look like zeros, maybe I's because they might look like ones, or they might look like a lowercase l too. So let's say that x is going to be your net winnings. So I say net winnings because I'm going to take into account the $5 that you had to pay for the lottery ticket. So if x is your net winnings, I'm going to make a little table that says what I'm going to win and then the probability of that outcome. So I'm going to have x as the top row, and then bottom row is going to be p of x. So you might see a table written horizontally, you might see it written vertically, you might see it written with borders around the outside. It doesn't really matter as long as you have the outcome and the probability of that outcome. So if you don't win at all, so let's write here that you lose, just to kind of mental note up across the top. It's not officially part of the table. Lose, and then we have win. So we can keep track. Those are the two options for this lottery ticket. If you lose, then you're out your $5. So your net winnings are a negative $5. So negative to say that we've lost, and then 5 is the amount of how much. Now, if you do win the jackpot, it's not 1 million. So let's write out 1 million. Lots of zeros here. You had to pay $5 for that lottery ticket. So we're going to take 1 million and then subtract $5. So here's my math over to the side. 1 million minus 5. We've actually won $999,000. $999,995 is your winnings. Now let's figure out the probabilities of each of those. So if you won the jackpot, you could have won with this probability of 0.00001. So I know this, 0.00001. And then it seems like we don't have enough information, but because there's only two outcomes, if we know the probability of winning the jackpot, then the complement, so 1 minus this probability, is the probability of losing. So that is 0.99999. So how did I compute that? Here's my math. 1 minus 0.00001. All right, and what we have completed right here, this is our probability distribution. So it tells you the distribution or the outcomes and how they're sort of spread out or distributed across the different outcomes. Instead of working by hand, I'm going to show you how to compute the mean and the standard deviation for this random variable using a spreadsheet, because it's easier and easier to get the answer when there are trickier numbers like very small numbers and very large numbers that would be challenging to put into a calculator. So first, we have to have our probability distribution set up. So the expected value takes the outcome, multiplies it by the probability, and then moves on to the next outcome, multiplies it by the probability, etc., and then adds up all the resulting products. So our mean is going to be -5 times its probability plus the near $1 million possible winning, multiplies it by its probability. And then that is your expected winnings. Losing $5 every time you play the game, you might actually win every so often. So on average, you're going to come ahead with $5 in your pocket. Now for the standard deviation, we have to do a little bit more work. We need to look at how far each number deviates from the mean and then look at a squared deviation, but then we have to weight it by the probability of seeing that outcome. Lastly, take a square root. So I'm going to copy this table again because I'm going to add a couple of extra rows to it. So I'm going to add a row that is x minus the mean. So I will take -5 minus 5, the mean, and then for the next column, I'll take this near $1 million equals 99995 minus $5 for the mean. So these two numbers here are the difference from your winnings from each individual game, net winnings, and comparing it from the mean. So on average, you're about $10 below the mean, or you're 999,990 above the mean. Now let's square that. So we're going to take x minus the mean and square that. So we'll go back, say -10 squared. The nice thing about the spreadsheet is we're going to have some pretty giant numbers, and you don't want to have to deal with that on a calculator because it can be kind of tricky to get all the numbers showing on the calculator screen. Okay, last step, we need to take these squared deviations, so not just a difference from the mean, a squared difference from the mean, but now weight it by the probability. So I'm going to take x minus the mean squared, and then multiply it by the probability of that outcome. So here's my x minus mean quantity squared, and then go back to the table and multiply it by the probability. So a squared deviation of 100 is seen most of the time, versus this really large number is rarely seen, just like it's rare to have won the lottery for this game. All right, so we have these two calculations. Now we have to go through and add them together. If your probability distribution had lots and lots of columns, then you'd have lots and lots of calculations, so you'd add up a whole lot more. So I'm going to write, this is my total, and I'm just going to add up these two numbers. There we go. So this is actually a variance. I'm going to put a little note there. This is the variance of the random variable, but if I want a standard deviation of the random variable, I need to take the square root. So I'm just going to say equals SQRT, so square root of the number. Push enter, and so we get almost $3,200. Now, if I was going to give this answer in a sentence, I'd probably round out to 2 decimal places since I am talking about dollars, so to the nearest penny. So on average, the net winnings are almost $3,200 away from the average winnings.